so in today's video we're going to have a look at some probability equations. This is quite a tough topic, okay, and the way I'm going to structure this video is I'm going to do one question, then you're going to do a question that's fairly similar. So do grab a piece of paper, grab a pen, make sure you make some notes on these questions that I go over, because you are going to have a go at one, and there is some quite extensive mathematics going on in these types of questions, okay. You're going to have a very good understanding of probability trees, you're going to have a good understanding of creating expressions and algebra and forming quadratics, solving quadratics, okay, there's a lot of maths going on here. I'm going to link as many of those topics as I can in the description, so do make sure you check those out if you're not sure on any of these. But we're going to get started, okay, so we're going to have a look at this question here, and it says there are some green counters and some blue counters in a bag. That says the ratio of green to red is 4:1. One counter is removed, not replaced, and a second counter is taken, and that's quite key there that it's not replaced. That says the probability that they're both green is 22/35. How many counters were in the bag before any were removed? So if we start to construct a probability tree here, and we have a look at the probability of green and blue. Now we only know the ratio there, we don't actually know how many are in there. So if we have a look at this as a ratio, we've got green to blue, and it's 4:1. We don't know how many lots of 4 and how many lots of 1, so we can allocate some algebra to this. We can say it's 4x, 4 lots of a number, and 1 lot of a number, 1x. So if I actually start writing this as a probability, I first need to know what my denominator is going to be. So add these both together, and we have 5 lots of x as our total amount of counters there. And now we can construct these two fractions. So green is the 4x out of a total of 5x, and blue is going to be the 1x. Let's remove the 1 there, and that is again out of 5x. Now we actually don't need to construct the full part of the tree here, because what we're actually interested in is the probability of them both being green. So really only need to look at the up part of the tree for this option here, where it's going to be green, green, but I'm going to go about constructing all the tree to start with anyway. Okay, I do think it's important that you're able to construct these and create these expressions, so I'm going to label this up green and blue, and we'll just think about what all these probabilities are going to be. Now if I take away one of the greens, I've got 4x, and I'm going to take away one of them. So I'm going to go 4x minus 1, and on the bottom I'm going to have 5x again, taking away one counter because one of them has not been replaced. Now they're the two that we're actually interested in, but we could go about constructing the ones below. So blue would be the 1x, again over 5x minus 1. I'm moving down here, so let's write that in. I'm going to get rid of this in a sec, but it'll be x over 5x minus 1 again. If we took a blue out, the blue would go down to x minus 1, and that'd be over 5x minus 1, and the green above that would stay the same, so it'd be 4x, and it'd be over 5x minus 1. So I mean, that's all the potential branches that we could have, but again we are only actually considering the green option here, because we've been given the probability of green. So if I went up the green and up another green here, we would go through those two fractions and they would equal 22/35. Okay, now what I'm going to do is I'm just going to get rid of the rest of the tree, because that's all we're really concerned about. You can save yourself a lot of time here just by constructing part of it, but it's good to be able to construct the entire tree there and think about what you'd actually get. Now if we do get rid of all of that, obviously when we're going across a tree we multiply, so we need to multiply these two fractions together. So we have 4x over 5x, and that is going to multiply by 4x minus 1 over 5x minus 1. There we go, and again that is going to equal 22/35, but before I set it equal to 22/35 I'm just going to work this out. So on the top we have 4x multiplied by the 4x minus 1. 4x times 4x is 16x squared, and 4x times negative 1 is negative 4x. Okay, just multiplying the top there just like a single bracket, and on the bottom we've got 5x times the 5x, which is 25x squared, and 5x times the negative 1, which is negative 5x. And then now that equals 22/35. So what we've got is we've got a fraction on both sides of our equation, and in order to remove the denominators from both sides we're going to cross multiply. So I'm going to times both sides by 35, which is going to move 35 up to the top here. I'm going to times both sides by this 25x squared minus 5x, which is going to move that to up to the numerator over here. And if I write that all out in one step, we have 35 lots of the left numerator. So we have 35 lots of 16x squared minus 4x, and that now equals 22 lots of the 25x squared minus the 5x. Okay, so I've just cross multiplied there so I've got a single line equation. Now what I want to do is actually just remove these brackets. So I've got some quite big numbers in here. The one that you're going to do is not so big, but if I actually multiply these brackets out, 35 times 16 gives me 560 x squared minus 4 lots of 35, which is 140, so minus 140x. Oh, there we go, 140x. And that equals 22 times 25, which is 550x squared, minus 22 times 5, which is 110x. There we go. Now we can actually rearrange this so we can get the everything on one side. So we've set it equal to 0. So if I subtract 550x squared from both sides, I end up with 10x squared over here. And if I add 110x to both sides to get rid of that negative 110 on the right, if I add it to negative 140, I get negative 30x, and that equals 0. Okay, now it equals 0. We're just solving a quadratic here. So there's a couple of ways you can go about it. You can solve it as it is, or we can simplify it first. I'm going to divide both sides by 10. So if I divide everything by 10, we get x squared minus 3x equals 0. And I'm going to just remove some of this working out here, so hopefully you've written this down. I'm going to remove this, get rid of this, and just bring that up here. So at the moment we have x squared minus 3x equaling 0. Now whenever we're solving a quadratic here, we need to factorise it. This doesn't factorise into a double bracket, but we can factorise x out. So we have x brackets x minus 3 equals 0. And we have our two solutions here. We've got the one in the bracket, which is x equaling positive 3, not the negative 3. And on the outside here, we've got x equaling 0. So we've got two answers. We've got to decide which one it is. Now, x in our case here is an amount of counters, and we can't have 0 counters, so it has to be the positive value there. Obviously, other than the 0, we can't have 0 amounts of counters, so 3 lots of the x value there. So x is 3. And it says how many counters were in the bag before any were removed. Well, if we look back at this original statement here that we made, we said there were 5 x counters, or 5 lots of this x. So 5 times 3, there we go, would tell us that there were 15 counters in the bag. Okay, it might have asked us how many green, in which case it'd be 4 times 3, or 12 greens, and 1 times 3 for the blue, or the 3 blues. Okay, so we've got 15 counters in the bag, and that's the end of the question there. So you have to construct your two branches of the tree using expressions, times them together, so you've got some algebraic fractions, creating your two fractions either side of the equal sign. We had to cross multiply to make it a single line equation, expanded it all out, made it equal 0, solved it, and then applied our solution to the question. So as you can see, a lot of maths going on there, but here's one that is very, very similar for you to have a go at, see if you can get the answer for this one. Okay, so here's your question. Pause the video there, have a go, and we'll go over the answers in a sec. Okay, so we've got green to blue counters, and it says green to blue is 3 to 1. So if we label this up as a ratio, we have green to blue, 3x to x. And in total, that gives us 4x. So constructing our tree, we're interested in the fact that they're both blue here. So if we have green going up, blue going down, keeping it in that same order, green would be 3x over 4x, and blue would be 1x again over 4x. Now I'm not going to construct the whole tree here, because what we're really interested in is blue again. And blue, if we took one out, it would be x minus 1, and on the bottom there we would have 4x minus 1. Okay, so I'm going to remove the top part of my tree there, we don't need that anymore, and we'll have a look at how we're going to construct this next part. So obviously what we need to do is multiply these together, moving across the tree. So we have x over 4x, and we are multiplying that by x minus 1 over 4x minus 1. And that's going to equal 1 over 20. Let's go back actually multiplying these. So if we multiply those together, let's see what we get. X times x minus 1 on the top gives us x squared minus x. And on the bottom, 4x times 4x is 16x squared. And 4x times negative 1 is negative 4x. Now that fraction there equals 1 over 20. And again, just like before, we just need to cross multiply. So times the left top by 20, and we get 20 lots of x squared minus x. and times the right top by 1. So we don't actually need to write that, it's just going to be 16x squared minus 4x. There we go. Right, I'm going to get rid of this tree so we have some room. Right, so actually expanding this out, if we go about that, we get 20x squared minus 20x, and that is going to equal 16x squared minus 4x. Now we need to make it equal to 0. To set it equal to 0, let's minus 16x squared from both sides, and we get, oh, I've written 16 as well as taking it away. So 20x squared, take away 16x squared, leaves us with 4x squared. Negative 20, add 4, leaves us with negative 16. And now that equals 0. Again, we can divide both sides by 4 here. So if we simplify this down, divide both sides by 4, let's bring it over here. We would have 1x squared minus 4x equals 0. Factorise it by x, so we can solve it. So we get x minus 4. And then we get our two solutions. So we have x equals 0 on the outside there. And we have x equals 4 in the bracket. So there's our solution, x equals 4. Again, it can't be 0. So how many counters were in the bag before? Let's have a look. Well, we started with 4x up here. So 4 times 4 leaves us with 16 counters that are in the bag before we started. Again, 3 lots of x would give us 12, 1 lot of x would give us 4, but the total amount of counters there is 4x, so 4 lots of 4 gives us 16. Right, well, we're going to have a look at a slightly different question. Okay, so we're going to treat this question in exactly the same way, but we've got something slightly different going on here. It says there are 5 blue and x red. So again, if we write our ratio this time, blue to red, it is going to be 5 to x. Okay, so our total this time is going to be 5 plus x, so I'm going to write it the other way. I'm going to write x plus 5. I just prefer looking at it like that, although it doesn't actually matter. And that is going to be our denominator. Now it says the probability that they're both blue, okay, so that both counters taken are blue, is 5 over 33. Work out the amount of red counters in the bag originally. So again, if we construct a tree here, we've got blue and red, blue to red. I'm not even going to worry about filling in the red one this time, I'm just going to go for the blue. So blue, there are 5 counters, and our total that we've worked out there is x plus 5. Now one of the counters is not replaced, so the next time we take a blue, I'll think about drawing the tree here, again I'm going to leave red out, but the next time we take a blue, we'll take 1 away from the 5 there, leaves us with 4 blues, and take 1 away from the x plus 5, leaves us with x plus 4. So that is that part of the tree that we need, okay? We don't need the red roots here, so we can get rid of those. They're the only ones that we're actually interested in. So if we have a look at timesing these together now, so we have 5 over x plus 5, and we're going to multiply that by 4 over x plus 4. And again, that is going to be equal to 5 over 33. Okay, so 5 over 33. But let's go about actually multiplying these first. So 5 times 4 on the top gives us 20. And then we've got a double bracket to expand on the bottom. So you can work that out to the side. What have we got? X plus 5 multiplied by x plus 4. I'm going to expand this out quite quickly. We get x squared plus 9x plus 20. And obviously just take your time expanding that as a double bracket. All right, let's tidy that up a bit because that's a bit of a mess. Right, 20 on the top over that. And we've got that that is equal to 5 over 33. So we've got a very, very similar process here. Look, we're just going to times both sides by 33 and times both sides with this denominator here and cross multiply. So we're going to have 33 times 20 on the top. 33 times 20, just doing this on the calculator, gives us 660. So we have 660 equals 5x squared plus 9x times 5, which is 45x, and 20 times 5, which is 100, so plus 100. Okay, next step, let's make it equal to 0. So let's subtract 660 from both sides. So I'm going to write everything on the left hand side. I'm just going to write 5x squared plus 45x. Subtract 660 leaves us with negative 560, and that equals 0. Now again, we've got a quadratic. I'm going to remove a lot of the working out here and let's just see where we're at the moment. Okay, let's get rid of all of that. Right, so we're at this point. So we've got a quadratic. We just need to make this a little bit more simple. So we can divide everything by 5. So if I divide everything by 5, because they're all multiples of 5, we get x squared plus 9x minus, and 560 divided by 5 is 112, minus 112 equals 0. Now again, I've shown you quite a tricky one here because that's obviously not the nicest to factorise there, but if we factorise this, it's going to go into a double bracket. Now obviously if you've got a calculator, this is quite nice because you can use the quadratic formula. We're going to assume we don't have a calculator at this point. We're going to try and factorise this. So the factors of 112, we can have 1 and 112, we could have 2 and 56, let's have a think, we could have 4 and 28, or we could have 8 and 14. Are any of these going to make 9? It doesn't look like it so far. What else goes into 112? Let's have a think. We could have 16 and 20. Oh no, 16 and 7, isn't it? Okay, 16 and 7. There we go. Again, I am just using a double and half method here to find all these factors. So I'm doubling 8 and halving 14 to get my next factors there. So 16 and 7 can make 9. So to make 9 in the middle, that'd have to be x plus 16 and x minus 7. Okay, and that all equals 0. So we've got two solutions going on in the brackets here. We've got x can either be negative 16 or x can be positive 7. Okay, obviously again thinking about this logically, we can't have negative 16 counters for the reds, so there must be 7 reds in there. X was red, so x equals 7, and we would just write red equals 7. And that would be our final answer there. Again, it could have asked us how many counters in total were in the bag originally. That'd be 7 plus 5, that'd be 12, but it's just asked us for how many red. Okay, so there we go, there's our answer for that one. Okay, now you're going to have a go at one very similar, nicer numbers, but here it is. So here's your question, pause the video there, and we'll go over the answers in a sec. Okay, so there are 4 blue counters and X red counters. So if we write this as a ratio again, blue to red, we have 4 to X, and in total there, that is X plus 4. Now if we write this as a probability tree, it says the probability that both counters are red is a third, so I'm only really interested in the red root. Now if I just have red going up just to save a bit of space here, it doesn't really matter which way we draw it, but red is going to be x over x plus 4. Okay, we don't need to worry about blue, and then red again would be x minus 1 because we're taking one red counter out, and that'd be x plus 3 on the bottom because one of those counters is gone, so it's not x plus 4 anymore, it's x plus 3. And if we times these both together, they're going to equal 1/3, that fraction given to us there. So x times, and you can always put a little times sign here, x times x minus 1 gives us x squared minus x, and on the bottom we have a double bracket again, and if we expand that double bracket we get x squared plus 3x plus 4x, which is 7x plus 12, and that equals 1/3. And again cross multiplying, so times this top by 3 and this over here to the 1, and we get 3 lots of x squared minus 3, and you can always just imagine that. I'm going to skip the step of writing it as a bracket. We've got 3x squared minus 3x, and that equals 1 times that denominator there, which is x squared plus 7x plus 12. And then again, just making this equal 0. So that's minus x squared from both sides to get rid of this one. And that gives us 2x squared. That's minus 7x from both sides, which leaves us with minus 10x. And that's minus 12 from both sides, which just leaves us with minus 12 because there's no numbers over there. And now that equals 0. Now again, they're all even, so we can divide them all by 2. So we can have x squared minus 5x minus 6, which equals 0. And that's quite a nice one to factorise there. Okay, 3 and 2 times to make 6, and they can subtract to make negative 5, or we could have 6 and 1. Again, so always just make sure you write down the factors. We can have 3 and 2, or 6 and 1, and the combination that's going to make negative 5 there, which also gives us negative 6, we're going to need x minus 6 and x plus 1. And that all equals 0. There we go, so we've got two solutions there. We've got x equals 6 or x equals negative 1. And in the case of the context here, we can't have negative 1 counters, so x is going to have to equal 6. It says work out the amount of red counters. Well, the red was just the x there, so x equals 6, and 6 is our final answer. Again, we already knew that there were 4 blue counters, so now we know there are 6 red, and that is 10 in total. So that's solving that one. Again, if you weren't sure on any of these, just go back, have another go. Make sure you've made some good notes on it. I've got one more question for you to have a look at before we finish. Okay, so you might have heard of this question or a similar question like this. It was quite a popular question. It was one that people really struggled on. So it says that there are n sweets in a bag, 6 of the sweets are orange and the rest of the sweets are yellow. Hannah takes at random a sweet from the bag and then takes another, and the probability that Hannah takes 2 orange sweets is 1/3. Work out how many sweets were in the bag originally. So n sweets in a bag, 6 are orange, the rest are yellow. She takes a sweet at random, doesn't replace it, takes another, and then the probability that 2 orange sweets is 1/3. This is different to the other two that we've done, but it's all a very similar process. It's solved in exactly the same way. So have a go, see if you can figure this one out. And we're going to go over the answer, but just see if you can create one after me not going over one that's super similar to it. So you've got enough information there off the previous ones that you've had a go at to have a go at it. So have a go, see what you get, and we'll go over the answer in a sec. So pause the video there. Okay, the answers for these then. So there are n sweets in a bag, so this time it's given us our total, and the option is either orange or yellow. And it says that there are 6 orange, but it doesn't tell us how many yellow. It just says that the rest of them are yellow. Now we know the total is n because it says n sweets in a bag, so the total take away the 6 for the orange would leave us with n minus 6 for the yellow. So a little bit different here because yellow is n minus 6, the total take away 6. Now we're only interested in the 2 orange sweets, and if we think about constructing our tree, and again we only need the orange root, orange would be 6 over n, and then another orange would be 5, 6 take away 1 over n minus 1. So as it turns out we don't even need to use that n minus 6, but it's always good just to think about what the expressions would be either way, because we could be given the probability of 2 yellows, but actually this one wasn't too bad. So if we go about actually timesing these together, they'll equal 1/3, so 6 times 5 on the top gives us 30, and on the bottom we've got n times n minus 1, which is n squared minus n, and that equals 1/3. Again, we're at the point where we can cross multiply, so we'll times this up here and we'll times the 3 up there, and we get 90, 3 times the 30 equals, so it's only 1 times the denominator here, so it's n squared minus n. Let's make it equal 0. I'm just going to minus 90 from both sides, so 0 equals n squared minus n minus 90. Again, you can write that the other way around if you want, but I'm just going to factorise it from there. So the factors that make 90, we could have lots, but we're trying to make -1 in the middle, and that option there is going to be 9 times 10. We're trying to make -1, so we'll have 0 equals, it'll be n, to make -1 we want plus 9 minus 10, so n minus 10. And again, we've got our 2 solutions there, so we've got the option is n equals -9 or n equals +10. Okay, obviously thinking about the context here, it's got to be the positive one, can't be the -9, so n has to equal 10. Now it says work out how many sweets were in the bag originally. Well, we've just worked out n equals 10, so this number here, the total amount is 10 sweets. Okay, there we go, and there's our answer. Again, we could say there are 6 orange, so therefore there are 4 yellows, but it asked us how many sweets there were in total, and there were 10 sweets. So that's the end of probability equations. I'm going to do another video looking at some harder questions on probability equations. These are already pretty tough though. They're right up there at the top of these, the top of this topic. So I will obviously make some more just on some slightly harder ones as well, just to sort of explore some of those. But that is the end of probability equations. So well done for sticking through all of that. You may need to go back and just have another look if that's something that you feel that you need to do. But obviously, if that was useful, if it was helpful, please like, please comment, please subscribe, and I will see you for the next one.